Today I'm going to go over some bitwise operators. To start, I'm going to go over AND, OR, and XOR, which are represented by the ampersand, the vertical bar or pipe, and the caret when used in C. You'd use these symbols between two numbers or as part of a compound assignment. So first, let's start with the AND. To start, we're going to write out two numbers, in this case 13 and 6. And we're going to write these out in binary form so we can see what's going on at the bit level, meaning that these are bitwise operators. So to AND these together, we need to see where there's a 1 in both numbers. In this example, we see there's only one place, the 4's position, and thus the 4's position is the only place where we put a 1 in the answer. Notice we don't put a 1 where there are a 0 and a 1 or two zeros. Now just to go over another example, in the same way we did the first, we put a 1 in our answer wherever we see a 1 in both the top and bottom numbers. In this case we have two 1s in the 128, 32nd, and 2 positions. And all the other positions have a 0 or a 1 or two zeros, and therefore we put a 0 in the corresponding position in our answer. So now we're going to go over the OR operation. So again, we're writing out our numbers in binary so we can see what's going on. And in this operation, you get a 1 when there is a 1 in either the top or the bottom number. Notice that the only place where we get a 0 is the 1's position, in which there are two zeros. That one seemed pretty easy. So now we're going to go over the XOR, which is represented by a caret again. And for our first two numbers, we're going to go with 13 and 10. So the way XOR works is you get a 1 when there's a 1 in either the top or the bottom number. You don't get a 1, however, when there's a 1 in both numbers or a 0 in both numbers. So in this case, you get a 0 in the 8's position because there's a 1 in that position in both numbers, and you get a 1 in all the other positions because there's a 1 and a 0 in each number in the corresponding positions. So let's go over another example because the last one it wasn't demonstrated what it happens when there are two zeros. And same as if there are two 1s, you get a 0. So basically you only get a 1 when there's a 1 in one number or the other, but not both. You get a 0 when there are two zeros or two 1s.
To finish this video, I'm going to go over left and right shift. And let's start with the left shift first. The left shift can be performed by using two less than symbols between two numbers or variables, or what have you. Let's start by writing out 13 in binary. And for this example, we're going to assume that this is a 4-bit number, though the same principles still apply for larger integers such as 16 or 32-bit or 64. So for this example, let's do a shift of 2 with no wrapping. When we perform this operation, we move all the bits 2 positions to the left and fill the remaining positions on the right with zeros. Here we can see the 0 and the 1 have just shifted over, and 2 new zeros came in from the right, and now we have 4. Now let's go over right shift. This will be slightly more complicated since this is often implemented with sign extension. To start, we will again, similar to the left shift, write our number in binary and put it in a 4-bit box, though like the left shift it also applies to 16, 32, 64-bit, etc. And we're going to do a shift of 2 to the right. This first example is quite similar to the left shift, as we'll simply shift each bit to the right and let the ones on the far right fall out of the box, and we'll fill the positions which would be empty on the left with zeros. The reason we are using zeros in this example, however, is because the most significant bit, the bit that would represent 8 in this case, was 0. Right shift does not always use sign extension, but it often does. Now for our second example, let's use 10 and do a shift of 2 to the right. This time, when our bits fall out on the right side of the box, and we have empty space on the left, we will fill it with ones. And the reason that we're doing it this way is because if this were a signed number, meaning it can be positive or negative, using 2's complement, the first bit represents or gives us an indication of the sign, and we would want to maintain that even through the shift. So hopefully I've drawn enough arrows here you can kind of figure out what's going on. And as usual, if you have questions, be sure to ask in class, and best of luck on your bit twiddling adventures.